All right. So, hello everyone. My name is Viraj, and we will be doing post-contest discussion for the contest Codeforces Round 944 Division 4. And today we'll be solving the first 7 problems. That's the problem G. And quite a fun contest, like basic ideas have been covered in every problem, right? So we'll be going through all the discussions and let's see what comes up as discussion. You guys are open to you're free to open your mics and discuss anything you wish for the any problem. All right, so let us start. So first problem, my first sorting problem, problem A, pretty easy problem, right? I think like barely the first problem is something everyone one makes. You will take two integers x and y as input, and you are required to print the minimum of x and y first, followed by the maximum of x and y in the second type. All right, so I think problem is like self-explanatory. I don't think I need to tell you guys what is the physical meaning of the problem. Just take up two integers and print the smaller of them, print the larger of them. All right, so let's say the test cases are pretty clear. Let's say you have 8 and 4 given to you. So you first print 4, then print 8. So not a big deal, right? Is this a big deal? And like, again, this can be written in any sort of method you want. Maybe you can just sort them out, use an STL function of min and max or whatever hits you first, whatever is good to go. So are we good to go on the problem itself? Like I don't think we need a very deep explanation for this problem, right? Let us just quickly look at the code. All right, so quick code to this and we'll see what happens. Yeah, so basic code. This is what just hit me in the first moment of time. Your solution can be a bit different. I will just simply say the input of x and y, and I will print the minimum, I'll print the maximum. All right. Now, obviously, the time complexity is going to be O of 1, right? Because I don't need any strong checks to actually do this, and space is also O of 1 because I am not taking any extra space to calculate my answer. So done and dusted problem works in the time complexity, and we can move on to the next one. All right, so problem B. Now, you are given a string S consisting of lowercase English letters. Your target is to rearrange the characters S to form a new string R that is not equal to S, or you will report that it's impossible. Impossible directly means that you will either report, you will simply say a no. All right, so you need to either print a yes or a no. And if you print a yes, that means you also need to print this new string R, which you think should be formed by rearranging something or the other. And so that you actually get a new string R that's not equal to S. So pretty like easy problem to understand. Let's say I have the string Codeforces. I can just simply print yes. And then this is one of the possible options for me to print, which is something that's different from Codeforces, right? So again, why do I know that this is one of the possible stuff? Because again, it's directly given in the output that there can be multiple answers. So for all those who are new out there, these are some things you can look into while reading the problem, the constraints, the how does the output should look like. And like this line of having multiple answers is always most of the time hidden in the output section. So if you, let's say, think that there will be only one answer but there might be multiple answers, you can actually look for this sentence. If the sentence is written, you know that there are multiple answers possible. So that means not only this answer is possible, you can maybe make some answer which you think might be possible. And it makes sense for me because even let's say for the bare minimum, let's say I push this C and I replace this with this S. So I have a new, I should say, a string that is named as, I should say, sword 46, something like that. That is also a different string. S, that's also a different string from S. So that's also a possible answer. So in questions like this, what generally happens is we can actually first try to dive into, put our energy into first figuring out when do I always think the answer is no. All right. So can someone tell me when do you always think the answer is no in this question? Like it's pretty simple.
When all the characters are same.
Exactly. All right. So Anand, Mohit, base condition was to check if there are two different characters or not. Exactly. So I think you guys get the direct idea, right? I know that I'm trying to rearrange something. And for all the possible combinations for me rearranging anything, it's pretty obvious that if I want to rearrange some characters and I need a new string, initially those characters should not be all same. Is that right? Is that correct or not? Yes, that's correct, right? So I have some string S1, S2, S3, S4. If all these four letters are same, then however I do their permutation, however, whatever combinations I try to make, all will look like this, all will look actually like the same string S. So whatever R I make, I am actually achieving S back. So that means I need a very basic check that these characters should at least have the unique count greater than 1. That means you cannot have a single letter that forms the whole string S. And then the argument rises as, all right, I have understood what is the no condition. Then what do I think is like, if this is the no condition, then besides this, is my answer always yes? If yes, how? And what should I print R? This is the next approach. So obviously, I know that I have, like, to my extent, I can think very clearly logically that I've almost covered, or I've actually covered fully all the answers which could have turned no. That means all the rest answers are yes. So any other string which has a unique character count greater than 1, unique char count greater than 1, I need an answer yes. But then the argument is, all right, you printed yes, but then what string should you print? Now remember, even the tiniest change from the original string S will give you a new string that is different. So Mohit is saying swap first character with character which is indifferent with first character. Great. That's great. That's great, Mohit. So we know that we are trying to make a very small change. We are not trying to just, like I should say, jumble up fully S. What you can do is simply find that very small single change which I think make my difference from S to R, and that can be done. And what is that very basic difference which can be there? We can print reverse as well, right? All right, so no, Anand, we cannot print reverse. All right, so I'll give you a simple case for this. Let's say the string was ARA, and the reverse of this is also ARA. Now, do you think your answer would be correct? Yes? No, Anand. Yes. So I don't receive that. This reverse is good. That means, like, what should I actually, like, ideally, what should I do? I should simply say that even if I sort, correct. If sort doesn't work, then print reverse. All right. So that's a good approach. All right. Correct, Omkar. That was I was going to. So, like, for all those out there who understood this problem being yes, the basic operation, the very basic operation which you can do is simply say, for the first index I, for which I find that S of I is not equal to S of I plus 1, I can simply swap these both letters and I can print S back. Will that work? Do you think that works? Yes, because I know I want to make a very small change in the initial string S to receive a new string R. And if there is only one index for which even I have swapped the places of two characters which were not same. So let's say the characters were A and C, now they became C in the main string. So let's say someplace here, someplace here, someplace here, someplace here. But these two characters got replaced. I know that these are two different strings. Is that right? So that means I can have a very basic code written for the yes case also. And this doesn't need any bit explanation now. So I think we can move on to the code look part for this, right? Basic code, what you can take is take the input of the string S, all right? And now what you can do is you can make a frequency map out of all the characters of S to just check whether you think that what is the current distinct count of characters in S. Now, this can be done in any method, all right? So I'm not telling you at all to use a map. Maybe you can use an unordered map. Maybe you can use a frequency vector sort of something, or maybe you can even have a S of I not equal to S of I plus 1 sort of a check with a flag, something like that. It's just a small part of implementation, all right? That's not going to be a big deal at all. The only point is somehow we just get the information, is my current string having the distinct character count or not? Now, I have used, let's say, an unordered map in this case. I changed my code a bit. I think it still should work. Just a small check. Yeah, I mean, it would definitely work, right? So I basically get out and print, finally get the frequency map of my current string. And then if the size of this frequency map is 1, then that means I have distinct character count only as 1. Is that right? So should I print directly no? Yes. And once I print no, I go to the else block. Now, what is else? Else is definitely printing a yes, because I just realized answer will always exist. Answer can definitely exist. And what will be that answer? That answer will be simply running a loop from 0 to, now, because I want to check from I and I plus 1, so I need an index before n. So that's n minus 1, so less than n minus 1. And then when I find S of I not equal to S of I plus 1, I can simply swap and break out. Is that right? Once I swap S of I S of I plus 1, printing S is going to be the correct answer. So I can see like a very good simple case for code forces now becomes is you simply replace CNO. So it's OD forces, something like that, OC forces. Yeah. So that's great. No need to use map. Correct. There's no need to use a map at all, Omkar. All right. The target is to somehow gather, do you have the distinct character count in the string as 1 or greater than 1 for you to understand whether the answer is no or yes. So you can do that with any sort of a structure. Like maybe you can use a flag and a direct loop to check S of I not equal to S of I plus 1. You can use maybe a vector of like 26 size to store individual ASCII value characters, and a map, an unordered map. Because the point is, can you see that S is very small? Like it's at most 10 characters. So that means I have a very, very high limit on time complexity, right? I can just use almost anything and it's still going to work. Even an n cube, n4 solution is going to work. So I know that this solution can be one of the correct solutions. This is definitely going to work. And this definitely fetches me the right answer. So I have no wherever I think that I have the same characters. Let's say A, this is all same. H, this is all same. So I print a no, else I print a yes. Now, because I have used an unordered map, like why did I actually use maps in this case was to actually get you familiar with the time complexity for all those people out there who might not be familiar with maps time complexity. All right. So because I used an unordered map, and unordered maps average complexity for pushing back, maintaining structures and everything is actually O of 1. So what you can actually argue is I'm running a loop that is in O of n complexity. Let's say n is the size of S. And inside that, I have a 1 complexity to actually push out and actually maintain everything. So I have a O of n complexity that's there to actually maintain this map. And then even for the for loop over here, I can see an O of n complexity. So overall, I can say n plus n, with which means 2 into n, which means actually simply n. Is that right? So now I have, now for the space complexity, because I have used a map and I can actually argue that the size of the space maximum argument of like taking S is actually 10. So I can maybe argue that the maximum size of this map can be 10. Is that right? Like 10 distinct characters, so 10 size of the whole map. So space is something that I'm using extra, that is O of 10. All right, so are we good to go on this problem? Can we move on to the next problem? D is simple problem, right? Not a big deal. Yes, all right. All right, so I have now problem C with me. All right, so let's read this problem. Clock and strings. So there is a clock labeled with numbers 1 through 12 in the clockwise order as shown below. So I have a clock, basic clock structure 1 to 12, looks like anything that's in your home, so not a confusion there. And now there are two players, obviously Alice and Bob, the most free people in the world. They have 4 distinct integers, A, B, C, D, and they are not more than 12. So either they have something in the range of 1 to 12. Now Alice will tie some red string connecting A and B, and Bob will tie some blue string connecting C and D. Now, do you think that the strings intersect? So you only have to print a yes or a no if you think that is the correct approach. Now, I think during the contest, I was not able to come up with the, like, I should say, most suited, most best time complexity sort of an approach. Right. And I mean, that's my bad part, because like I was but again, I think maybe we can form some more optimized codes if that's a great idea. And maybe the discussion panel is open for you guys to actually comment if you think that there's a good idea for this. So let us simply first discuss a few test cases, and then we'll deep dive into what code I have written. Maybe we can optimize as we go, and we can see what sort of a good code can we create out of this. All right. So A, B, C, D is given, let's say, for like 2, 9, 10, 6. So 2, 9, 10, 6 is actually this case itself, right? So in this, I can see that Alice, if let's say took the numbers 2 and 9, she tied a string, and then Bob tied a string, and they definitely intersect. Is that right? So for all the other test cases, you will be easily able to draw up a clock. And if you just join the points, you will easily able to answer yes or no. So there, I don't think is there any confusion in the test cases, right? Is there some test case which you will not be able to answer yes or no quickly? Even in the mind, you can picture out, right? You can easily visualize this out. So what finally boils it down is, how do I actually code this up? What idea do I actually use to make this work? All right. So Sagar has put up a very intricate piece of code with a lot of if and else checks. All right. So Sagar, that's great. I mean, Sudhir also put up a code, minimum, maximum. All right, counting this, count of 2, count of 0. Exactly. So like Sudhir, I like somewhat, what I've done is somewhat like you. All right, but I'll try to like better visualize this thing. All right. So iterate from A to B, count if both the end exists. If count is 1, yes, else no. Exactly. Kind of like that. So like that is what something I wanted to do, but then I don't know what hit me. And maybe like just to get you familiar with different data structures. So maybe I used a different approach. But then again, you get the general idea. All right. So let's discuss what idea are we picturing in this. So naturally, I have a clock with me. All right. So I'll draw this with black. And naturally, I have a clock with me. And then obviously, like the markings which are there in this, all the markings which are there in this, Alice is definitely there and she has a two numbers. So like, let's say she actually made these two numbers like this. Let's say this is the red string she tied. So I know that Bob, if he like takes up his share of two numbers and tries to like string out the blue string, for it to actually intersect with this red no, thread or red string, whatever Alice has tied, I know that if like, let's say I can imagine Alice to divide this clock into two sectors. I can maybe take this, I can maybe say that this is one sector and this is the other sector. Is that right? Alice tying up the string has divided the whole clock into two sectors. Now tell me very logically, if Bob's string actually coincides, or actually like, sorry, not coincides, intersects rather, with the string that Alice has tied, it would make sense for me that one point of Bob, if let's say C and D, so either one of them has to lie in this sector and the other has to lie in this sector. Only then I know there's going to be a point, let's say somewhere here and a point somewhere over here, with which a connection would give me an intersection. Is that right? Do you think that's true? If both the points are in the same sector, let's say this is sector 1, let's say this is sector 2. If both C and D belong in the same sector, then do you think ever these strings are going to intersect each other? No, right? So this is like basic imagining of circles and sectors. So this is what hit me also. Most probably this is what hit you guys also. Fairly decent problem. That means somehow if I'm able to like first deduce, like what now I have done is actually what I just visualized was what I had coded up. Again, as I told you, there can be multiple approaches to this. Many of you must have calculated some mathematics behind this, min and max and stuff like that. I did very straightforward thing. I simply took all the numbers possible in the sector 1 in, let's say, a set, or in some data structure, let's say some data structure DS, and all the possible numbers in this sector, I'll name this S1, and all the possible numbers in this sector in some other data structure. All right, so I actually use this set, but again, you can use anything. All right, and then what I did is I simply checked that, like many people are commenting that count sort of a approach. I simply checked that if I find C in either S1 and D in S2, or C in S2 and D in S1, then I print a yes, else I print a no. So fairly straightforward. Yes? Is that right? One sector simply min of AB between max of AB. Correct, Sudhir. Again, so that's exactly what's there. Like if you boil down the mathematics behind this, it's simply that the direct part. Again, but then again, like just a difference in implementation, not a big deal. All right. For even like for simpler like problems like A, B, C in diff4, diff3, implementation is not a big part. You can implement it in 1,000 ways. All right. So we'll look up the code directly. All right. So what have I done over here? Now, I have actually swapped A and B if I feel A is greater than B. So I took the input of A and B, A, B, C, D. And then if I feel A is greater than B, I swap AB just to make sure that A is always less than B. Now, why have I done this is because of this, what I can do, I can now run a loop from A plus 1 to less than B, and I can name this as a sector. So if let's say this is A and let's say this is B, so this is actually the traversal I would be performing from A to B. Is that right? Yes. So I would be simply saying, let me run a loop from A plus 1 to less than B, and I will insert all that stuff into a set. So I mean, you can more optimize this right over here. I can maybe use an unordered set, all right? So that's something we can do. So I'll be using an unordered set. I think it should still work, right? So basic stuff, I will push out all the numbers from A plus 1 to less than B in a one set. I'll call this S1. And then I will create another set S2. Now I have kept a very small check, just that what hit me at that moment. I will iterate on all the numbers from 1 to 12. And if that number is neither a, neither a B, and it neither exists in the initial set S1, then that means it is going to exist in the sector 2. Is that right? Do you guys agree with this? Yes? So I will push that I number in the set S2. Now I can simply check if C belongs in S1, that means is count is giving me a good value, and it D belongs in S2, or either this condition is true or D belongs in S1 and C belongs in S2. Either of these, if any of these two conditions are true, then you get a or operator by a true false or a false true method. You get a simple true and you will print a yes. And if both conditions turn false, only then you print a no, because then you very well know that they belong in the same sector. So they will like they will definitely, I should say, give me a no answer. All right. I checked if both are in the same sector or not. First, I use XOR, bitwise problems. All right, so great, Amit. I mean, like people who might be familiar with XOR, bit of manipulation, we can do a good approach with that also. Also, it's XORing x greater than a. All right, so I get the approach. Correct, Amit. That's great. All right, so again, as I said, the implementation behind the first two problems to diff through diff 3, and mostly even sometimes diff 2 a problems, the implementation is not a big part because the problems are so easy generally to understand. If the logic is clear, they can be implemented in many number of ways. Like, I mean, the experienced people must know in this. Right? Am I wrong in this? Right? So you can implement this in any sort of format you want. And this is something I did. Now, for this piece of code, let's quickly look at the time complexity. Just for you to get familiar with unordered sets run again in O of 1 complexity for everything. So you can simply say that I will have a complexity, like time complexity of. Now, like running this loop from A to B, I know that these numbers are very small. So I have a 12 numbers established, right? So even like, let's say I have a 12 complexity running, 12 is so small, I can even like barely say that this is actually constant time. Do you agree? Like for pushing everything in the set, that's also constant because I've used an unordered set. And then these loops are very small, right? Like 1 to 12 is such a constant factor that you can almost take that as a constant time. Am I wrong in this? Yes. So your time complexity is very small. Like even if you can report this as O of 12 or maybe even O of 1, and like O of 1 solutions are possible. So this solution is also O of 1. People who did this maths, swapping, min max, that's also O of 1. So time complexity becomes O of 1. Roughly, I should say, roughly it would be O of 1 constant. And then space for me now, because I'm maintaining sectors, I can take a space maximum to be of 12 order, because maybe it could happen like not exactly in 12 order, like maybe I would be skipping numbers. So maybe I can say a 10 or a 12 order, maybe approximately. But then again, this is again so small that I can even consider this space approximately constant, right? So I'm just using an order of constant in this because it's so small. But then again, if you have made this problem without any sets or without any min max, without some basic mathematics, then obviously, you know, this is a O of 1 solution which you have created, and that definitely works. So are we clear on the idea? Right? Good, good problem. Can we move? All right. Yes. Cool. So let us see problem number D. All right. So who were you guys able to solve problem D? All right. Yes. All right. So I think that means problem. All right. So Swami, let's try to look up what happens in problem D. Even understood. All right. That's something different. All right. So I'm here for you guys to make it easy, make it clearly. All right. So now, I mean, again, I think there might be an optimized version of my code piece of code again, but then idea would be again same. The idea which I would see. Count the number of changes from 0 to 1 and 1 to 0. All right. So counting the number of changes from 0 to 1 and 1 to 0. All right. So that's also so Adarsh is saying no. What are you saying no to, Adarsh? The above approach is wrong, I think. Also, maybe I think Sagar maybe must have like outputted and like submitted this code, right, Sagar? Is that right? Yes. So if like this is working for Sagar, so I think this is definitely working, right? That's if that's the case. All right. There's a base case he has handled count equal to 1. All right. All right. So like what I've done is actually like I also solved this problem like this only, but then I have actually uh, 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 what should I say? I have actually restructured the problem in a different method just to like get you through the idea of how I imagine the problem. All right. Again, your voice is breaking sometimes. All right. So is my voice clear now, Mohit? All right. All right. So I actually also solved this like that only. All right. I mean, basic idea. But then again, I have restructured the problem into a bit longer code. But then this is all for the beginners out there, just so that you can easily imagine what would happen, how that thing would be there, and how things would look like. All right. So this is why I've done that part. All right. So let us discuss this problem. All right. So you are given a binary string and you will find the minimum number of pieces you need to cut it into so that resulting pieces can be rearranged into a sorted binary string. So this is given to you. Find the minimum number of pieces you need to cut it into so that resulting pieces can be rearranged into a sorted binary string. So that means the string that is given to me, I need to place some cuts. I need to smartly place some cuts. Let's say the string is S1, S2, S3, S4, S5. I have a 5 string. What can be the rating of problem? Let's come to problem. Well, let's say. So let's say I am trying to place cuts over here. And the moment I place cuts, I create some parts. And the target is the parts which I have created, somehow if I rearrange them, like let's say if this is part 1, part 2, part 3, then let's say I place part 2 first, then let's say maybe I place part 1 first, and let's say I place part 3. I know that doing that should result in a string that is totally sorted in order. Now, what do you mean by sorted? Let's say the string is binary in format. That means you only have zeros and one. So if it's sorted, that means the string either looks like all zeros, right? All zeros, or it looks like all ones, or it kind of looks like all some zeros at the first and then some ones. Yes, these are the three possible cases for it to be looking like sorted, right? That means it's pretty clear to me that from this, it should be pretty clear. I need to place cuts so that I'm able to create either of these three cases. So let's try to picture the problem now. Now, if let's say the whole string initially has all zeros, then what do you think is your answer? Your answer is 1. Because if the string has all zeros, then that means that's a single part. Do you need to place any cuts? No, you don't need to place any cuts. Is that right? Let's say this is case 1. Let's say case 2. You have all ones. Do you need to place any cuts? So the number of pieces you have will be 1. Is that right? What is case 3 now? Case 3 is obviously the string has some zeros and some ones. So it's a mix of zeros and mix of ones. That means I might be required to place cuts. I'm not sure. I might be required. Now, why am I saying might? Because let's say the string, like in the cases itself also, you can see that let's say this string, the string that already looks like some zeros and then some ones, again, same case. The answer is 1. That's the only part, right? I have some zeros and I have some ones. So the answer is clearly 1. But then the other part is, what if the answer for all these three cases are 1, and beside that, anything is not having answer 1, what is the basic difference? What can I identify? So why am I actually going very detailed in this problem is to make it very clear for the beginners out there. All right. So 0, 0, 1, 1, 1, like let's say there is a pattern giving like this, the answer is still 1 because you can take this whole part and it's still sorted. So now you have just answered the queries when I would have asked you, when do you think the answer is 1? Have we covered everything? When do I think the answer is 1? Yes. So that means what is left with me is to discuss the cases when I have zeros and ones in the string, but they are not looking like 0, 0, 0, 0, and then some ones. So that means the answer is going to be something beside 1. It's not 1 anymore. It's definitely going to be greater than 1. How much, what, that's my target. So first of all, I realized that if it is not looking like 0, 0, 0, 0s and 1, 1, 1s, that means someplace or the other, I would actually be having a 1 and a 0. Is that right? So let's say this is the string. Let's say there is a string. And let's say it starts, it has some characters. Then there is actually a 1 and 0, and there are some other characters. Now, do you think this is something that's a problem with me? This is a problem for me? Yes. I would necessarily have to break the string over here. Is that right? Because I know 1, 0, if it is kept like this only in the string, it is never going to help me create a sorted structure. Because after 1, I don't want a 0. I want all ones only. That means I need to place a cut. Is this clear? This is right. This makes sense to me. I need to place a cut over here. So that means it's pretty much clear for me that I am trying to place cuts only at positions, trying to place cuts initially, like for this case, trying to place cuts at positions where I feel that I have a 1 and 0. Yes, if I have a 1, 0, I will necessarily have to place a cut. This is definitely true. I will again increase the cases likewise. There are some more corner cases to discuss on this, but then this is very true. Like this is something I don't even need to argue. If there is a 1, 0 anywhere, I need to place a cut, because if I don't receive a sorted structure. So how can I imagine my overall problem to be now? I can simply say that, let's say I'm talking about this string. In this string, very clearly you can see they have placed a cut over here, that is 1, 0, and then they have placed a cut over here, that is add 1, 0 again. Can we all see this? Yes? We can all see this. Like it's clearly observable. So that means if let's say like I'll give you an argument and tell me, do you think that's wrong? That's right or wrong? After I have made cuts at all the places where I received a 1 and 0, I will have 3 types of strings remaining in the whole string. 3 types of segments rather remaining in the whole string. Either the segments will be all zeros, either the segment will look like all ones, or the segment will look like some zeros and a 1. Are these only the 3 possibilities? After I have actually like, I should say, made a cut everywhere where there was a 1 and 0, I made a cut in between. Then the segments, like let's say this was the string and I cut it over here, here, here. So these 4 segments are going to be of these 3 types only. Is that right? Amongst these 3 types only. Can you all agree? No. All right, why I? I mean, you guys are getting the problem, right? I'm saying something like you can argue that. You can argue that 0, 1 can be only 0, 1 can be only once. All right, so Sai, I said like all right, for like 0, 1, you don't make a cut anywhere, do you? So
Like, sir, like if we have 2 or 3 substrings which are having 0, 1 in that order, then we can only take a 1, 0, 1, right? Like,
all right, so all right, so are you talking about strings like 0, 1, 0, 1, something like this? Yes.
yes, sir.
Yeah, so in this case again, like where would I place a cut? Like up till here, like I'm trying to build the problem. Again, I know the answer is still not there and there are some corner cases, but up till here, what I'm trying to argue, do you think that's right? Like for this problem, I will obviously make a cut over here. Now, the segment I've received is a segment of the third type. I have some 0 and then some ones.
Again, we should make another cut, right? Here.
Where would I make a cut? Yeah, that would be all right. You're trying to get the answer finally. I'm just trying to ask you that up till here, is this right? What I've said. Again,
Yes.
I know that you will have to make more cuts. I'm coming to that. But then up till here, are we all clear that I will either like if I have made a cut at all the places which were 1, 0 of the type, then I have segments that are either of the 1 type, 2 type, or 3 type. Yes.
Yes, sir.
I'm not trying to overcomplicate the problem again. All right. So I know that there is a very simple solution to this if you get the part. But then the beginners need to easily able to visualize this so that they can optimize it further. The people who are commenting in the code part of directly checking a 1, 0 and 0, 1, that's a very optimized version. Is that right? So like I wanted to have a more visualized version of this problem, because binary strings are something many of the times diff4, diff3 problem as will come into. I didn't understand that third case. All right, so Jatin, I'm simply saying that, like, let's say the string, like I'll argue this string only 0, 1, 0, 1. In this string, if you make a cut at a place where you actually find 1, 0, there is only one place you have a 1, 0. Yes, you make a cut over here. My argument is, do you not receive, did you not receive two segments, and both the segments are of this third type? So the argument is, if you make a cut like this with a 1, 0, if you place a cut between, you will only receive segments which are either of the first type, second type, or the third type. There is no other possible combination. Yes? Is that correct? Now, why am I doing this? I'll show you why am I doing this. All right. This is just for visualization purpose. All right. Then maybe I can discuss the optimize also with you. So now, like, everyone agrees with this part that after I've made cuts at 1, 0, I will either have type 1 segment, type 2 segment, or type 3 segment. Now tell me, all the type 1 segments, if I want some rearranging that should happen. So I have gathered, let's say I have gathered 4 segments with me. Let's say in this, I have the type 1 segments, 0, 0, zeros, all zeros. Like in that whole part of the string, substring, whatever you can call that, I have all zeros. If I want a sorted binary structure, will I not place all such segments in the starting of the string? Is that right? Let's say I call this type 1, or type 0. Will I not place strings having type all characters as 0, the segments, all such segments clubbed together, concatenated in the first part? Can I not do that? I would want to do that, right? Because I want to make initially I want all zeros from the left hand side, because that's the sorted structure. So I will keep all the segments of zeros in the start. Now, all the segments of the type 1 structure, that is meaning like, or rather I can keep like one, maybe it should not confuse you. Type 1 structure actually means, or let me not do this. I'll use the same analogy there. Type 1 means all zeros. Let me do something like this, all zeros. And then type 2 means all ones. All right, all ones. All right. So I have a type 1 structure, type 2 structure. I will keep all these segments of type 1 structure together in the start, all the segments of the type 2 structure together in the end. So I have some zeros. That means I will be clubbing some zeros together. And then I have some ones. Yes. Now I will be left with only the type 3 segments, which are of the pattern some zeros and then some ones. Example. Yes? Is that right? Now, the argument is, like, for visualization purpose, the argument is, if you have, let's say, if you have the count of this type 3 structure only as 1, then can you place that one structure, one segment directly over here, and you will receive your answer? Yes? If let's say I only have a single segment that looks like 0, 0, some zeros, then some ones, then can I not club everything out, concat everything out? Yes, I can, and I will receive an answer. But what if this count is greater than 1? What happens then? If let's say I had one structure, one segment that is of zeros and ones looking like this, then some one more structure that has some zeros, then some ones. What happens then? Can I just concat them together and can I keep it? No. This is where I need to further realize that I, by the same analogy, need to break more parts. Yes. How many parts do you think I need to break? Like, let's say I had 2 such segments that are some zeros and some ones. Then can I break, if the count is, let's say, C, then can I break C minus 1 parts on the place of where they are having a, let's say this is 0, 0, 0, 0, 1. Can I break them over here? Can I break it at this place? Yes. And when I do this, I will now again receive a segment that is all zeros, and I will receive a segment that is all ones. And then this 0 segment can go over here. This 1 segment can go over here. And I can just keep this, like, why did I say C minus 1? Because if C is the count, I can just negate, I can just remove one such segment of zeros and ones, like one such segment like this of initially some zeros and ones. I can keep it as it is, and all the rest segments can be broken further. That one segment can, now why am I doing this? Why is it like, why will you argue that why are you taking C minus one segments? Why don't you take all segments, break all the segments? That's also fine. But then I want the minimum number of pieces, right? So greedily, it would make sense for me that just leave out one piece, don't break it, keep it as it is of zeros and ones, and keep it in the middle. Keep it in the middle, so you will have some zeros coming over here, and then some ones coming over here. And then other parts besides this one part, that is C minus one parts, can be broken. They can be broken. The zero of that part can be concatenated over here, and the one part over here can be concatenated over here. Is this clear to everyone? Yes. Now, the other way to look at this is simply actually like to calculate the 0 to 1 transition and 1 to 0 transition. That's also a problem. That's also a great thing. But then visualization is also something that needs to be covered, right? So I know I'm trying to like maybe overcomplicate the problem. For all those who understood this idea, that also works for them. But then again, we need a good visualization also, right? Why do you think this would have worked in the first place? This works because you understand this also works. Yes? So is there any problem with this piece of logic I just told you? No, there's no problem. All right. So Swami got this. I think many of you commented yes when I asked you if you solved D. So I think all of you guys are good to go on this D problem. We can look at the code part, right? All right. Also, this is code. Now, again, I know this is a very lengthy code. You can maybe create a shorter code than this for this 1, 0 and 0, 1 part. But then again, I'm like trying to tell you, trying to focus on this point many times that I wanted a more visualized solution to this. And just not to overcomplicate this, the solution of generally do that also works. Do we get a recording? Yeah, you get a recording. You definitely get a recording. You get a recording, even you get the code. All right, Chandra. All right. So let us like what I have just said, I have just boiled that down to code. So like again, boiling this down to code has been great. Like I have done a very, can you please elaborate that 1, 0 and 1, 0 part of this? All right, all right. I'll elaborate that, Jatan, also. All right. So let's just try to first simply see this problem, right? So like what I've done is actually like, I mean, I know there might be better optimizations than this. I was just out of my mind to just write any piece of basic code to make it run at that moment of time. So again, but it's pretty simple to understand if you get this idea. So what I've done is I've taken an index vector, and this is going to store all the indices where I feel that I have a 1, 0 part. That's the breaking part. All right, because I don't want to actually break the string. I just want to store where I would break. So I'll store this I index where I break. Let's say I see that S of I is not equal to S of I plus 1, and S of I is actually 1. Then this is the index I'll break. This is I. So initially I'll push -1. Then I'll push all the indices which are actually of this type, where I think that S of I is not equal to S of I plus 1 and S of I is equal to 1. And then I'll also push back n minus 1. Now, why have I done this? I have done this so that I can finally get the two end points of every segment. Do you understand this? Like after I have broken down the whole string, what can I actually check? Like after I've broken this down to, let's say I've broken down to 4 segments, what I wanted to very quickly check is, let's say I'm talking about this segment. Is this segment of type 1, type 2, or type 3? Now to do that, like I think the constraints, all right, so S is very small. I can obviously like maybe iterate directly in the string itself. So that's also one problem. But what if S size was large? So what you can do is, if you think that this string is of the type 1, then the first letter and the first character and the last character is also 0. Then that if both are 0, that means it's of the type 0. It's it's of the type 1. Everything is going to be 0. Yes. If let's say I have 1 over here, 1 over here, then it's the type 2. And if I have 0 over here and I have a 1 over here, then this is a type 3. Yes. Because if I have a 0 at the start and 1 at the end, that means somewhere in the middle, I had a 0, 1, making it a 0, 0, 0, and then some ones pattern. Yes. So to do that, my idea was to store all the indices I can store to get the segments, like two pair of left and right of every segment. All right. So this is what I've done. So to do that, I have initially pushed, like, can you show the example in the case of 0, 1, 0, 1? All right, I'll do that. I'll do that. So I'll initially push -1. That's the starting index before even 0. This is -1. I push -1. And then wherever I break, I'll push this I, push this I, push this I. And then at the end, I will also push n-1. So once I've done this, what can now happen? Let's say I name this I1, I2, and I3. What can I now do is, I can start taking two pairs. So I can take this pair, and this is a segment. This pair of indices, this is a segment. This pair of indices, this is a segment. And this pair of indices, this is a segment. And what would be the LNR of this segment? It would naturally be, obviously, like this is, if this is -1, you can very clearly see that it would be like, if this is the segment L and R, if these are the two, numbers L and R, then from L plus 1 to R is actually the string. Yes, that is why I've actually pushed -1. So for, if you were wondering why did I push -1, so this is every time that would happen. Now next time I would have shifted to I1 being L and I2 being R. So I would be checking from, like, checking the indices L plus 1 actually and R. So basically actually checking I plus 1 and I2. Then simply I2 plus 1 and I3 plus 1 and n-1. So this is what I've done. All right. So I think that's clear, right? I mean, again, very like haphazard sort of a implementation detail. Implementation can be done in any format. All right. Now I have, like, for your, as we talked about types, right? So I have a count of 1, that is all the type 2, actually, you can say. Count 0, that is all the 0 formatted segments, and count of 0, 1, that's all the segments that look like zeros and ones. Some zeros and then some ones. So now I'll simply check this simple check. I run an iteration from 0 to index.size -1 because I need two pairs. Now, if S of index of I plus 1, meaning like L plus 1, as I showed you, is 1, and and the index of I plus 1, that index is also 1. That means the segment is all ones. So I will increment C1. Else, if it's 0, 0 both side, I'll increment C0. If it's 0 and then it's 1, I'll increment C01. Is it clear? Yes. Now, what we do the next thing? Next thing would be, I now have the answer with me. So maybe I can name this answer for you. Answer is actually, like, initially I know the answer is the count of segments that were all 0 or all ones. That's the summation. So I add up C1 and C0. That's the definite answer. Now, because I discussed this as a corner case, I have handled it with like this. If I think that 0, 1 segments are greater than 1, then I would add on to my answer C minus 1, discuss C minus 1 over here, or C0 minus 1 into 2. Why into 2? Because I know every time I cut the string, I will have two separate parts. So every single part is contributing two parts now. So that is C0 minus 1 into 2. And next, I would say, if it's greater than 0, that means I need one final part that would come in the middle part, and that's only one part. So I'll increment answer only by 1. And then I'll print my answer. Is this clear? Now, somebody asked for the test case 0, 1, 0, 1. So what I'll do is, actually, I'll show you the indices also for this, and I'll show you the answer also for this. All right, so let me print this array. All right, so can we see this? Like, I have -1 over here. Then I have a 1. This is the first index where I would require a cut over here. Then I have 3. This is the other index I would require a cut. Then I have the last index, that's 5. Now, the segment between -1 to 1, or rather -1 plus 1 to 1, that's 0 to 1. This is a segment. 2 to 3, this is a segment. And 4 to 5, this is a segment. Yes? Have we distributed segments? Is this clear, Siddharth? And then it's a simple check, and you get the whole output. All right, so now, Jatin wanted, and like, I mean, maybe some people also want the better version of code of this, right? Maybe like just to get the whole hang of what is happening. Yes. So Omkar also has put up an easier approach than this. So definitely, again, I told you this is not the best approach out there. Reason being, I wanted to like visualize the stuff, but then we can have a better approach than this. All right, so I'll discuss this approach now for all those people who get the idea. All right. So if we actually look into this code and like look into this idea and try to optimize this just directly, what am I essentially doing? Like first I realized I was breaking 1 zeros, and then I'm realizing I want to break zeros 1. Wherever I would have found a 0 or 1, I would want to break it. Is that right? I do want to break it. But then I am also handling a corner case where I feel that the count of breaks should not be like, if I have more, like the count is greater than 1 of this 0, 1 structure, then I know the breaking should not happen to every part. It should only happen to C minus 1 parts, and 1 part should remain as it is. So what I can do is I can simply put this in code format, and I can simply check, like I can like remove all this code part. All right. And I can actually do this something like this. I can say that if I feel that, let's say the S of like current S of I index, the current S of I, that is the index I'm standing at. So I'll make this with S, and let's say C is the count that I had. So I'll say if S of I is not equal to S of I plus 1. So that's a discrepancy, right? I know that either it's a 1, 0 or it's a 0, 1. So I would want to definitely increment by C, because that's a cut I need to make. So I will increment C. But then again, I need to also make sure that if at the end of counting all the C's, the count of this 0 and 1 is actually positive, then I don't want the answer, like I don't want to print exactly C, I want to print C minus 1. So what I can do is actually keep a flag variable with me. Let's say call this, let's say this is a flag, F, and this is initially false. So I can simply check if S of I is equal to 0, all right, this is 0, and S of I plus 1 is equal to 1. Then I'll make this flag as true, because that will tell me that this current cut was actually a cut of 0, 1 type, not of 1, 0 type. This is a 0, 1 type. And if it's a 0, 1 type, I do want to leave one such cut as it is. I don't want to cut everything. I want to leave one cut as it is. So when I get the answer C, I will check first that is this flag true. If this flag is true, that means answer should not be C, it should be C minus 1. So I will decrement C by 1, and then I can print C directly. Do you think this is going to work? Like, I mean, it should... So all right, so it's showing up a small problem. That means Omkar, so all right, this approach was not right. Do you think like you can find the mistake in this? Add 1. All right. So if you're adding 1, why so cause of segment got accepted. All right, so this got accepted. So I think I had a rough idea on this. Like, what code did you send? This says I plus 1 is equal to 1. So am I doing something else in the code part? All right. So I mean, obviously C should start with 1, right? I think that is a part. Yes. So now it's right. Keep X as 1. Yeah, I missed that part. Sorry, my bad. All right. So this idea again works. So why did I keep C as 1? Because again, as like many people were commenting in this, I don't need the number of cuts. I actually need the number of segments. Yes. So if I want the number of segments, I know that segments is going to be cuts plus 1. So initially, if I start C with 0, I will have the number of cuts. I want the number of segments. Good to go. So I think like both approaches seem right, right? And the point is, are we able to visualize that? Yeah, this is something I could have done. This is where I was breaking the part, and this is the corner case. So the corner case of 0, 1 is something we had to quickly identify. All right. All right. So I think basic problem, we can move on to this. We should actually discuss the time complexity directly. Time complexity now, this is going to be definitely O of n. Any doubt in this? Y of n, I'm running a very basic loop, right? From 0 to n. And space, I'm not using any extra space, so this is O of 1. Good enough. Is there a guide where I can set up my VS Code that way? I think there might be a guide for this. I'm not sure. All right. All at Omkar. Yeah, that got accepted. Correct. Like Omkar, I remember, like I have given this from my alt ID. So the solution I actually submitted from my main ID was something like this. I was actually checking some, like I was checking with a different variable in this part. But then again, small part. All right. So we can move on. Yes. Good to go. All right. So next problem. Problem E. All right. So I think like problem E, like how many of you guys solve problem E? How many of you people were able to solve problem E? No. Yes. All right. Also, like problem E, like I'll go ahead and directly tell you this. Like generally, like let's read the problem and then try to understand. Problem E is a very direct implementation problem. All right. It's not a very tough problem in that order. But then the problem is with its time complexity. All right. So let's read the problem. Timur is in a car traveling on a number line from 0 to n, point n. So you have the point 0, you have the point final point n. And the car is moving from the point 0 at minute 0. All right. So now, because it's moving from the point 0 at the minute 0, you are also given some k plus 1 signs on this sort of a number line from 0 to n. And Timur knows that the car will arrive there at the minutes 0, b1, b2, so on till bk. So you have k plus 1 points because you have a 0 also added to this. So you have total 0-based indexing. That's a k plus 1 total size. Now, knowing like this information that I have the order of minutes that arriving, I know that the sequences A and B are going to be strictly increasing. It makes sense for me, right? I know that the car is not like I cannot have same time for two stops. Like car is obviously something that's going to take time. So the time which is given where the finally car reaches at some point of time, let's say it reaches A2 and B2 time, A3 and B3 time, this pattern, the sequence is increasing. So strictly increasing, to be very specific. Strictly means strictly like strictly increasing would mean that I don't have a like greater than if it's increasing, I have a greater like I have a of I being less than a of I plus 1, not actually less than equal to. This would be increasing and then this would be strictly increasing. So like simple problem to read and understand. Now, they have very clearly said that between any two adjacent signs, the car travels with a constant speed. So what do you think is the meaning of this? Like what can I deduce from this? The thing which I can deduce from this is like, let's say I have this stop. This is stop 1. And then this is stop 2. And let's say the time to reach here was T1 and then the time to reach here was T2. So the time difference between T1 and T2 and the distance difference between the stop 1 and stop 2, the speed is constant. So we know the speed formula. Yes, speed formula is very simple, distance upon time. Yes, meter per second, kilometer per hour, whatever you can name that. So I know that this speed is constant. Now, what's the important part of this? Like, why do they have mentioned speed being constant? Because that gives us a actual like that's what is helping us solve the problem. Now, Timur is going to ask you Q queries, and each query is going to be the type integer D. And then Timur wants you to output how many minutes does it take to reach the point D, rounded down to the nearest integer. So we'll come to that part. That's not a big part for us. But then, like, why did I talk about constant speed and then why this point? Let's try to quickly picturize that. Let's say Timur asked you how much time would you reach stop 1? What would your answer be? T1 directly? Yes. Like I know that in T1 time he's reaching stop 1, so I can print the answer T1. What if I've asked you for stop 2? Time taken for Timur to reach stop 2. What will your answer be now? T2 directly? Yes. Is everyone following with this? T1 for an answer to stop 1 and then T2 for an answer for stop 2. Now, but what if I would have asked you some number in this number line in the middle part, let's say somewhere over here, then what your answer would be? naturally your answer would be T1 plus something. So time taken for you to reach stop 1, that's obvious. Now you also need some time, that's, let's say, call this time T, taken for you to cover this distance. And then the reason why they have mentioned constant speed is you can now calculate this T distance, T time, sorry, by realizing that if I have a constant speed, then I can just take that speed into consideration, multiply that speed with this time, and I wanted the time, sorry. So if I get what is the distance between this top one to this red marker I've kept over here, let's say call this D dash, then if I want to calculate T can be simply, I should say, distance upon speed, and the constant speed I did calculate, that's S. So this can be D dash upon S. Yes, works. So this is the reason why they have given you the constant speed sort of a statement over here. Now, if you want to like cross verify this with the test cases, you will see that they have given almost the explanation for every test case, like for 1, 2, and even 4, and they only had like almost 4 cases. So once you like read the problem and then you want to verify this, you will get the idea. That is clear, right? I get this idea, this is going to work. So now the problem boils down. I think it's because of precision. All right, so Sudhi, let's try to see that. What's the reason for precision? All right, so I'll try to actually picture this for you. Like how did I see this? We'll see this in the code part. So it's an implementation, right? But even if you get the idea, Sudhir, that's a great part. You did get the idea. Now implementation is something that's a secondary part to this. We'll come to that part. So now I know that I can actually break this down. Like I can very clearly see the breaking down of this thing that's happening, that the answer is looking something like this. T1, that is this time taken for the stop, for me to like take the stop, plus this D dash by S, where D dash is the difference between this marker. All right, that's pretty clear. Now the point being is, I want T1 initially. Is that right? Now let us try to first look at the constraints. Now n is given in 10 power 9 order. That means you will have 10 power 9 number of different points. So on different speeds. Yes, I mean k, sorry, k is given, right? So ak. K is total. So k, this k signs being, k can be very huge, 10 power 9 order. And then the queries is in 10 power 5 order. So let's not like, they can ask on this number line 10 power 9. Yeah, kind of, you can say that. So when I say that I have 10 power 9 signs, all right, and n also being in a 10 power 9 order, and then AI, that's the number, is also in n order. So it's again in 10 power 9 order. Now tell me, if you understand the constraints, and if I ask you, how would you have like to calculate the difference between the marker of this red marker and stop 1, it's going to be mathematics. That's very clear. But then if I ask you, tell me how would you calculate T1 initially? You will be given these two arrays. This is array A where all the stops are given, and then the sign stops are, this is the array B where all the times are given. So for you to finally get that T1 is something that had to be added, you need to first get the stop. You need to find the stop which is just lower or equal to the red marker. Whatever red marker I have been asked in the qwith query, I want that I receive, if I get the first position that is less than equal to, I should say, this, then I know corresponding to that index, I will also receive the time. Do we all understand this? Yes? Now for me to realize that I need this stop, because I cannot iterate directly in the array A, being the reason that this is in a 10 power 9 order, I need a better optimization to find this first stop. Do we all agree to this? Yes? Because if I directly iterate, I'll be exceeding the time complexity. This is where the whole like crux of the problem lies. Exactly. So others got it, right? Now, I know that the array A is also increasing and the array B is also increasing. So if I ask you, if you want to find, like the problem has finally boiled down to, if you want to, or the sub problem rather, tell me the first place where the number is less than equal to, rather you can say, or like, let's rephrase this. If I am able to find the index which is not less than equal to D, let's maybe call this marker position as P, let's say. All right, so not less than equal to P, then I can maybe run a binary search sort of a structure to answer this sub problem. Yes. So for this, like, if I would have asked you for P, which is the first index where you think that you will receive a stop value, which is not less than equal to P, you will say stop 2. Is that right? And you will directly receive this in a binary search complexity. To be very specific, binary search, that means in a log n complexity, log of n complexity, because you know that array is increasing. So I can run a binary search, and binary search is optimizing very well. So for this ith query or this qth query, you will very easily get the, I should say, stop value. Is that right? By finding this first index. Now, the statement I just gave you, the first index that is not less than P, that means it's greater than equal to P. All right, so not like this, sorry, greater than equal to P. This is actually a definition of lower bound. This is actually a definition of lower bound in like an STL function in lower bound. Or you can actually write a binary search directly for yourself. But then again, I used a small STL function for this. So I think like you guys are familiar with this. So I can use a lower bound to actually get this stop. And then this stop and the stop before this is actually the segment in which P will lie. Do we all agree? Yes? Can we all agree to this? Please take one test case, either fourth or second. Yeah, I'll take that test case, Adarsh, don't worry. Can we all agree? If I find this index, then don't you think this index, let's say this is index I, and the previous index, I minus 1, this is going to be the segment of distance between which the P marker lies for the qth query. Is that right? And if I finally get this, I know that time of B of I minus 1, you can maybe take that, would be the time T1. I will quickly receive that. And then to calculate this D dash bias, that's also going to be very quickly possible. So I would have finally optimized my total solution from, let's say, I was iterating in the queries. So I would require a O of Q solution, and O of Q, inside this O of Q, in log and complexity, I would be easily getting this T1 value, and then everything beyond that is constant. So will I not receive a complexity that's like almost like Q log n sort of a complexity? Yes? Or not exactly like, not Q log, you should call this as Q log n, but rather the search space on the structure is actually in K. So this should actually be Q log K. Almost. Yes? Is that right? Do we agree to this? What lower bound I could not understand. All right, so Swami, what I did was lower bound is a function. It's an STL function, which is actually a binary search in itself. What it does is it's going to take an array and it's going to take a value. So let's say this array A and a value V. And it's going to return to you the first index, which is greater than, which has a value greater than equal, the value greater than equal to the value PV you pass. So if they have for 9 station in first test case, then you travel to from 0 to 9, then that would be O of n. I'm sorry, I didn't get this. If they are for 9 station in first test case. It's a first test case that way. No, again, no. Like to find this binary search, I'm running this binary search on the array, right? Now, what's the size of the array? The size of the array is K. Right, Adarsh? Am I wrong in this? So, like, do you think you get a, yeah, correct. All right, so it's clear. All right, so Swami, as I was saying, this is a lower bound, or for all those people out there who will not be able to get this lower bound part, this is a lower bound. you give the input array A, you give the input array V or some value, let's say I'll call this value P only, and it's going to return to you the first index where the value is greater than equal to the value P. So naturally, if P is over here, and this is the array A that's going some stops, then this is stop 1, stop 2, so on, so on. Then it's going to return to you this index. Yes, stop 2 index. Yes, Swami, because stop 2 index has a value, or like on the number line, it has a value greater than equal to P. It's the first place. Yes. And this place and the place previous to this, it's going to be the segment where P is contained, because this is the first place where the value is greater than equal to. So this place and the previous place is the segment where P lies. So I have finally, like, my target was to get this two part, the segment stop 1 and stop 2, for me to calculate the speed first, because I need the speed, right? I need the speed. I need d by t. So I needed two stops in which P lies. So I finally got those two stops. Because of the previous stop, I also get T1, and then I can finally get the answer. I got T1. I also got speed. Because of speed, I also got D dash. That would be P minus stop 1. That's the difference. And I also received the time T. Got it? So this is again a very implementation based problem. Can you all realize this? Yes. So the idea is to realize that the constraints are high. I need an optimization. And this optimization is very clearly, like, they have mentioned it a lot of times, that it's like the array is like increasing. So all these hints are there in the problem for you to realize that this problem can be optimized. That's definite. It needs optimization, but it can be optimized with binary search. So reading of the problem is very important. Are you clear on this? Now, once this idea is clear, can we now look at the code part? Yes. So this is going to be the code for all those, like, maybe you can crisscross this and see what did not work for you. I took N, K, and Q input. I took the array A input. I took the array B input. Any problem? Then I have taken the input of the, I have iterated in the Q queries. Now I take the input D. This is the D they were talking about. D in every query. Any problem? And then what do I say? Now I find the lower bound, A dot begin, A dot end, comma. Then this is like a syntax part. All right. So passing the array A from the start to the end with the value D. And then I finally like minus A dot begin. All right. So this is what I have finally. All right, Omkar. So I did not, like, are you saying this code is wrong, or is the code wrong if you take upper bound? I don't get that, because like this is an accepted solution. All right. So I think I can go. It should be there. It should be there. All right. I'll try to tell you what would happen. So I found the lower bound, right? And finding the lower bound, I now have the index. I'll call that index IT. This is the index where I feel that I have a position greater than equal to the current marker P, or this D, whatever you can call that. Now, why have I done IT minus minus is, if I'm standing at this index I have decremented it and made it come over here. So if this is index I make it index I minus 1. This is why I've done IT minus minus. So once I do that, what can happen is, now I can call this index and the index plus 1, and that is going to be the stop 1 and stop 2. So this is, like, I'll mark with this green pen. This is IT, and this is IT plus 1. Yes, Omkar. Do we get this now? What do lower bound gives? All right, so lower bound gives you a value that is not less than the first value, that is not less than the value you passed. That means greater than equal to value. Okay, got it? First greater value, first greater than equal. Yeah, greater than equal to value, not greater value. All right. All right. So I have received this value. I do an IT minus minus. So I get the previous index with me. Cool. Now, if I feel that this IT index is -1. That means this initial lower bound value was 0. That means what could have happened is I had asked you to calculate, like, I never used lower bound. So all right, not a problem. Then what is upper bound? First grade. Yeah, correct, Gautam. Upper bound is first grader. All right. So again, as I said, this is implementation part. This whole problem is about implementation. How do you write the binary search? It's totally up to you. Use your lower bound, use your upper bound. As long as you get the concept, your target is to somehow, in good time complexity, get this T1, get the two stops, for which we will get the time speed, speed, the distance, the difference, and the net time. This is your target. If you're able to fulfill that target with lower bound, upper bound, a custom binary search, it's totally up to you. Yes? All right, cool. So now if IT is -1, that means this was the first stop. So I have placed actually a marker that is before, like it's either it's before or at the first stop. First stop as in the first place of the array A. So what I can do is I can, if that is the case, I will handle that separately. If that's the case, I can directly calculate first the distance. That would be directly A of 0. Because if it's the first stop, that means the distance of the first stop on the number line is actually from 0 to stop 1. So from 0 to stop 1 is simply the distance stop 1. That is A of 0. Similarly, time is B of 0. And then what do you think is the distance? Like, what do you think is the net time you will receive? You will receive definitely D into, you will have the speed. And now, like, I mean, this might be a part where many of you must be getting an implementation error, maybe, right? What have I done this is, because I wanted, like in the question, it was written, rounded down to nearest integer. If I divide like D dash by S, it's indirectly saying I'm dividing D dash by D by T. If I take T top, it's actually into T. Yes. So this is very small mathematics. Do we get this? So now what I've calculated is actually the difference, which was simply stop 1, a time, stop 1, the D, that is the distance, because it came before then equal to stop 1, into time by distance. And because I have not maintained any double type or anything, you can say, you will definitely receive automatically rounded down integers. Because in C++, you know that it automatically rounds down everything, unless you explicitly define it to be. Right? We are clear on that. So that is D into time by distance. And if, let's say, you go in the else part, that means there was actually a segment of stops between which the D part was coming. So for that, implementation is direct. You find out the distance, that's the difference, that's the D between stop 2 and stop 1. So how do I get that? A of IT plus 1 minus A of IT. Time B of IT plus 1 minus B of IT. And then how do I get the, like, I can maybe take this as a different variable, maybe. You can call this as D dash, right? D something like, was like middle D something, maybe. I don't know. Maybe you can name it something like this. So, and you can, that is this part, D minus A of IT. What is this? This is the D dash. Because if this is D, or this is P rather, this is D, then D minus this stop 1, this is the difference. So that is D dash. Now this is the speed, this is the, difference into time by distance. So this factor is definitely there. Yes, as we discussed above. Plus, what do I need more? I need this T1. So what is this T1 time? This is definitely B of IT. And then I print it out. And then when I finally like end my output, I can like, I wanted to print it everything directly in one single line. But after that, I can finally like change my lines and get the next query output. So is this clear with everyone? Is the implementation clear with everyone? I try to keep it as simple as that. Quickly take one test case. All right. I'll take one test case. All right. Too many variables. All right. I'm sorry for that. If that's the case, let me take one test case. Let's say I'll take the 4 test case. All right. Test case number 4. So what I'll do is actually, let me print this IT for you. How's that? Let me print this IT. All right. And let's see what is going to happen then. So let me run this piece of code. All right, or maybe I can call it something like this. Just to make you clear on this, index equal to, and then I'll print IT, and then I leave a space, then that's the difference. All right. Can you see this? Is this visible? So I'll talk about the last case. Yes, this is the last case. In the last case, there were 3 queries, 2, 6, and 5. So in the number line, you had something like this. Yes, you had only actually one, right? So you had only one stop that is on the number line from 0 to 6. This is only one stop. And the time you took over here was 5 to reach it. From 0 time, you took 5 time. Now they first asked you for 2, 6, and 5. So can you see for 2, I am receiving -1 index. Why? Because I would have received 0. Because 0th index would have been the first place where I find a value greater than or equal to 5. Yes? Yes, Adarsh. And then when I subtract 1 from it, it becomes -1. So index is -1. Now, because index is -1, it clearly means this is some, like the marker is actually some place just before than equal to the first stop. And I can clearly see that, yes, the first stop is at 6 and I'm asking for the position 5. It's definitely before than, it's less than equal to the first stop itself. So I can directly go in this if check, and then if check is clear. Calculate A0, A0 means 6. Calculate B0, B0 means 5. And then D into 5 by T, that means 5 into 5 by 6. This is actually 25 by 6, right? Am I doing something wrong? Yes? All right, sorry, this was 2 actually. Sorry, my bad. This test case was 2. Sorry, I did not see this. So I was calculating for 2, right? So this becomes 2 into 5 upon 6, which clearly means I have 10 by 6, and this is an integer division is 1. So am I not receiving the answer 1 over here? Yes? Now can you dry run this out for the other cases also? Correct? Is everyone now clear? Do we have any problem in this piece of approach? Again, like multiple approaches, multiple part, not a big part. Please share CFID for submission. Yeah, I'll do that. I'll do everything like that. Not an issue. All right, so like a fun problem if you look at this at implementation and a small binary search sort of a realization. And what do you think is the time complexity now? As we discussed, O of Q into log K and then space complexity. What do you think is space? Like I'm taking space to store the arrays. That's definite. So I know that space is O of K, or rather K plus K, which is actually 2K, which is actually K only. So I know that I have a space that looks like O of K order. Yes, this is running in O of Q. This is running in log K, and I have a Q log complexity. So are we clear on the whole code now? Can I move on? All right, so I think we are good to go. We can move on to the next problem. Yes, cool. All right. All right, so problem F. Now, how do you, like, how many of you were able to solve problem F? This is where, I mean, things are going to get interesting. Problem F and problem G are good problems, I should say. All right. All right, so let us read the problem. Problem is like directly, it's very clear like what it is trying to ask you. It's very clearly telling you that you need, given an integer r, find the number of latest points that have a Euclidean distance from 0, 0 greater than or equal to r, but strictly less than r plus 1. So the problem is very direct. All right. All right. I see what Omkar has written. All right. So we have to take in float. All right, not float. Like I'll try to picture the idea for you guys. All right. I've tried to keep the code as clean as I can. All right. So find the number of latest points that have Euclidean distance from 0, 0 greater than or equal to r, but strictly less than r plus 1. So Euclidean distance is defined. It's defined as the distance that's the square root of x square plus y square from 0, 0. So they have given you the direct mathematical formula also what they're asking you. And they also have told you this r, and you just want the number of points. All right. So now they've given the explanation of the test case is also pretty clear, right? They have given 1, 2, 3, 4, 5, 6, 5, and then this big number also. But for the first 3 cases, They have very clearly like given a very good diagram for this to make you understand that these were the maximum distances there could have been. So they have marked that all the blue triangles had a distance between the limit greater than equal to 1, but less than the limit 2. So if I would have wanted the first answer, that is answer for R1, that means all the points Euclidean distance with R1, right, greater than equal to, see, count 1, 2, 3, 4, 5, 6, 7, 8. Then I can see that all the red point total, like red square count is actually 16, which becomes the answer for 2, and then 3, then 4, and so on, so on. All right. So can we have to take in float because of R plus 1. All right. All right. So I have not done this with float. All right. I'll try to like argue how I have done this, and let's see how do I get the whole idea. All right. So first of all, look at R. Now R is in a 10 power 5 order, right? Now because R is in a 10 power 5 order, like, do you think you can brute out this ideology? Like, what if I tell you, just on this infinite grid, just go on keeping all the points and then figure out how many number of points you have and stuff like that. Like, it's not possible, right? Like, it's very clearly visible that it's not possible for me to brute out for every point. Yes. And added to this, like, to just like better out the optimization, I can clearly picture one thing. Like, what if, let's say, by some piece of algorithm, I was able to get the number of points, the total number of points for which the Euclidean distance is less than R plus 1. So let's say I get the total count of points P1, which have the Euclidean distance less than R plus 1. So let's say Euclidean distance is less than R plus 1. And then I also get the total number of points which have the Euclidean distance less than R. Then do you think P1 minus P2 is going to be my answer? Do you think P1 minus P2 is my answer? Yes? Can everyone agree with this? So that means, like, now look at this part. Like, I'm trying to tell you how do we come up with approaches. Like, look at this part. I argued that if I was able to come up with some piece of code, let's say that piece of code is inside this black box, all right? Some piece of code which gave me all the points less than having the Euclidean distance for R plus 1, then can I not just use the same piece of code to get all the number of points less than R? So do you think I will have to write only one time this code? So whatever this code is, we'll discuss what this code can be. But if I write this code, I can use this 2 times. I can once get the point count for P1. I can get there for P2, and the difference is the answer. Is that right? That's correct. That's correct, right? So that means I'm trying to build up some intuition. That means somehow or the other, I want this piece of code. If I get this piece of code, I might not have to write 3 separate pieces of logic. I can use this piece of code for P1 also and P2 also. So now the discussion falls is what this piece of code should be. Yes. Now I'll start looking at the constraints. R is an order of 10 power 5. So what do you think is the expected time complexity? Like, what do you think is the expected time complexity for this? Like, can you make a R square solution? Something like this? No, right? Can you make an R log R solution? Yes. You can maybe even make an O of R solution. That's also right. If I'm talking about in the terms of R. So R square is definitely not possible. But then R log R is possible. Even O of R is possible. Is that right? Why am I discussing this? Because this is kind of giving me a hint that somehow or the other, I want to calculate my number of points in a time complexity that looks like O of R log R. Now, why will I argue? Like, let me argue how do I picture that to be? Like, tell me, like, you look at this structure over here. All right. Let's say I would have asked you firstly for less than 4 points. I would have asked you less than 4 points. Sorry, less than 4 distance. So for less than 4 distance, you will say all these points are correct. All these points, the green, the red, and the blue points, all these points have a Euclidean distance less than 4. Yes? So how have I broken down the problem is, let's say this is your grid. All right, let's say this is a grid. First of all, tell me very clearly, because I'm squaring X and Y, do you think this grid is, this diagram is symmetric? Or do you, can you argue that even the diagram, if like they would have drawn diagram bigger than this, shown you for other points also, don't you think this diagram is symmetric about the y-axis? Symmetric about the y-axis. First argument. Yes, symmetric about the y-axis. I'm just trying to make some observations. Yes. So what can I do is, what can I picture is, if let's say I ask you, what is, and also again, symmetric about the y-axis, and then also, if I ask you, is it symmetric about the x-axis? Again, your answer is yes. It's symmetric about the x-axis also. Is it not? Yes. So that means if I am able to get the answer for this first quadrant, like answer as in, if I would have asked you, what are the points, or the number of points rather, which have a Euclidean distance less than, let's say, 4 in the first quadrant, then don't you think by some mathematics you can very easily mirror and calculate the number of points that would have fallen in the second, third, and fourth quadrant also? Because you know everything is symmetrical. Am I arguing? Am I saying right? Into 4. No, not exactly into 4, but like we get that idea, right? Not exactly into 4, I should say. But then I've tried to broken it down. I'll tell you how. But then we get that part, right? We get the symmetricity. Like we understand it's symmetric. So answering for one quadrant will definitely somehow or the other get me answers for second, third, and fourth quadrant also. Correct? Is everyone able to follow this? Now, why am I doing this? Now tell me, if I have asked you a value less than 4, I want all the points less than 4. Because I want less than 4, correct? I want less than 4. Then what do you think are the possible values of x? If I want a distance less than 4, d less than 4, then what are the possible values of x? 0, 1, 2, 3, and 4. Sorry, not 0, 1, 2, 3, 4. 0, 1, 2, and 3. Yes? Do we get this? If I ask you, what are the possibilities of x for creating a Euclidean distance less than 4, then you will say x coordinate can either be 0, 1, 2, and 3. Yes? That's right. Yes? Now, what about y? Now, if I tell you, you have the possibilities of x as 0, 1, 2, 3, what would happen? If these possibilities are something you need to iterate on, d is fixed, right? D is fixed. D is only given once to you. Sorry, not d, rather. Let's keep this r. R is given only one time to you. So, you know, r is something like I have less than 4, which I'm trying to find. Let's say less than 4 I'm trying to find. So r is fixed. Now, in this fixed r, if I have the x possibilities of 1, 0, 1, 2, and 3, if I run a loop with an iterator I on this range, what would happen is, my next question would be, this for loop will have a complexity of O of r, approximately O of r. Yes, because if like what I'm doing, if r is less than 4, that means I'm running a loop from 0 to 1, 2, 3. Right? So approximately I have a complexity of O of r. Yes, I'm running this for loop 4 times. And now what I can ask is, tell me, if I ask you for each x, what is the maximum y you can keep such that x square plus y square is like the root is less than r, or you can actually say this as square, if you square both sides, x square plus y square is less than r square. If I ask you what is the maximum y you can find for a fixed x such that the value is less than r square, then don't you think this maximum value y, whatever you find this, let's say I'll call this value as y dash, then all the value before or equal to y dash would be a good pair that could be formed with x. Yes? I want the count of coordinates x comma y, right? So if I fix x to be 0, if I always say that my x is 0, I am trying to find all the possible y's. And if I calculate this y dash, that is the largest y which still satisfies this equation, all the numbers before y dash and y dash itself will satisfy this equation. Is that right? Do we all agree to this? Yes. Like let's say x is 2. So, and let's say I was talking about less than 4. So I have this value is actually 16 now, and this is 4. So 4 plus, what are the possible values of, like, the largest value of y you can keep over here? What do you think is the largest value of y you can keep over here? You can keep a 3. Yes, that's the largest value. If you keep a 3, you will receive a 9, and 4 plus 9 is 13, which is definitely less than 16. Yes? Is that right? You can keep a y value. You can keep a y value to be equal to 3. Can you keep a y 4? Do you think you can keep a y 4? No, we cannot keep a y 4. Yes. Now, if I cannot keep a y 4, can I keep any value above 4? Obviously, no. And if I can keep the largest value 3, then do you think I can keep y as 2 also and 1 also as 0 also? So for 0, I know I have 3, 2, 1, 0. All these 4 combinations are true. And can you identify that this question which I asked you to find the largest y, this is sort of a monotonic predicate structure. Monotonic predicate structure. Like this is big words, but like what I'm trying to tell you is, for a x, can you not binary search on y? Can you? Like if I fix a x, and if you want to answer the question largest y such that this equation is satisfied, don't you think you can binary search for this? Do we all agree to this? We can binary search. Yes. Can we not binary search? Because I know that for some y's, the answer is true, and then the answer is becoming false. So this is sort of a monotonic predicate structure. That means if I find this largest y where the value is true, I receive the best largest y. And all the possible below y's are also correct. Now, my answer is, like my question is, if I like get this y, how do I get my answer? I get my answer by symmetry. Because now let's say, like imagine for this, let's say x was 0. And I was asking for r less than 4 or d less than 4. Your y would have turned out as 3. Is that right? We just discussed. Yes. Let's say I would have kept, let's say x, even let's say I kept x as 2 also. So you can see 3, right? Can you see this? Like can you see my mouse pointer? You can see my mouse pointer, right? So you can see this, like this is x0. Sorry, this is x2. Sorry, this we discussed x2. From x2, y can be 0, 1, 2, and 3. That's the maximum y can go. From x3, maximum y can go is 0, 1, 2. Is that right? Do we all get this? Yes. Do we all get this? Now, if let's say I gave you y value, then what you can do is, by symmetry, your answer for x equals to 2 contribution would be, it would be definitely y is 3. So I have 3 points. On both sides symmetry, I have 3 points. So that means I can say 2 into y minus 1. This is for a x. And then if the x is not 0, if let's say x is something greater than 0, then I can again do an into 2 to this. Why into 2 again? Because I have for x positive, and the same symmetry would be there for x negative. Do we all agree to this? Yes. So if x is 0, my point counts can be simply y2 into y minus 1. And if x is greater than 0, it will be 2 into y minus 1 into again 2. Can we agree to this? Yes. So now, how do you think my time complexity differs now? Like how have I optimized my time complexity? For every x in this O of R solution, I would answer my query in how much search space. Now, what do you think is the maximum y can go? Y can also go in a maximum order of R, right? So if I run a binary search, this inside logic would be O of log of R. Anyone y -1? -1. All right. So all right. Good question. All right. I think I did not get this. -1. All right. So Piyush, why am I doing -1 is y was, let's say in this case, y became 3 for you. So x was 2. Can you see my pointer? This is x2. So this is x2. For this, you received y3. That means you have 3 points on this side, 3 points on this side. Yes? Is that right? Sorry, I'm sorry. This should be +1, right? If that's the actual confusion, I think. Not -1, +1. I mean, I'm sorry for this. All right, I got a bit confused on this. So if let's say you receive y, you get a y is 3 in this case. That's the largest y you can keep. So the number of points for x2 would actually be 7. Yes. So this would be 2 into y plus 1. That's 6 plus 1, that's 7. And then because these 7 points are same points which could have been kept for x -2, you again multiply it by 2. Now do you get it, Piyush? Thank you for correcting me on this. All right. It's not -1, guys. It's +1. All right. Yes. Do we all get the idea now? So do you think, like, can you see the symmetry? How am I using the symmetry? I will calculate for the first segment of this coordinate, maximum largest y I can achieve by binary search. And then by mathematics, I can just calculate the number of points on the second, third, and fourth quadrant also. And this gives me, like, if now, like, if this is the number of points, I can take maybe a P1 point count and I can add up to that every time I calculate for every x to every y. And this gives me point P1. Similarly, I will, like, I have calculated this for less than r, let's say, like less than r plus 1, let's say. I will calculate this for less than r. This would be called for, this is for P1 points, this is for P2 points. And then P1 minus P2 would be the answer. Can we not traverse in the square as fashion in the shown diagram and check the condition of each points? All right. So, like, tell me, all right, one thing, like others, the answer for this, like 1984, what do you think is the answer? Like, what do you think the order of answer is over here? 10 power 4, yes? Others. So, for just a small r, that's in 10 power 3 order, you have a order of 10 power 4. Yes? That is the difference, actually. Let's say you want to calculate P1. Don't you think the P1 points are going to be very huge? Like, the count of P1 points is going to be very huge. Can you imagine this? Like, I don't need to, like, mathematically prove this, but I can very well picture that r being, let's say r was given the maximum value, 10 power 5. Then for 10 power 5, don't you think you will have a lot of points? And most probably those points will be greater than 10 power 8 order, 10 power 7, 10 power 8 order. And just trying to, like, mathematically argue on the basis of this input. For such small count only, you received 10 power 4 points. That's the difference points. Can visualize. Yes, Adarsh, exactly. So because of this, you can very well easily get a TLE. If you actually go about calculating this square and this pattern and stuff like this, you will get a TLE, because there are so many number of points, you will never be able to calculate the correct answer directly. That means we need a better optimization than this. So this is the optimization I did. I first broke down symmetry. Then I saw for each x, I can run a binary search to calculate each largest y. If I calculate the largest y, every answer below that is also true. And then by symmetry, I can get my count of points. Now, is the approach clear to everyone? Do you have any doubts? Square won't give full answer as, yeah, exactly, Praveen. That's also one point, right, others? So not exactly square would always give you the right answer. The pattern would not always look like a square. It might look something else, right? It would be symmetric, no doubt. The polygon or whatever you can maybe name that, whatever you can call that, that would be symmetrical, but it won't be always a square. Yes. All right. So I think the approach is like it's like I have tried my best to give you guys the whole piece of idea. Now, if you guys have any doubt, you are again free to open your mics. You can ask this, or should I proceed to the code? Let us try to see the code part. All right. So where is the code? Yeah, this is the code. All right. So over here, I have created this points function, and then I've taken a R in this, and then I've taken an E in this also. So I'll just part of implementation tell you what E is. Let's first let's see this. I want to calculate, like, this is not like I have named this S1. You can call this as P1, and then this is P2. All right. All right. All right. So now what have I done over here? All right. Like, maybe I should have not taken E rather. All right. So, that's a fault on my part only, I should say. But then again, like this was mathematics. Like how do you come up with mathematics? That's totally up to you. All right. Like I took E because like that's an extracted variable. I could have actually omitted and maybe kept only with R and R, but then that's fine. All right. Uh, Again, implementation, not a big deal. You get the idea. You will like it becomes a homework for you. Implement the binary search on your own. If you're stuck anywhere, obviously the doubt support is open for this. All right. So I call this function points, pass this R and 0, and then this gives me P1. And when I pass the parameters R and -1, this gives me point P2. All right. So essentially what it does is passing these two parameters together is helping me finally deduce what is happening. So this is giving me all the points less than R plus 1, and this is giving me all the points less than R. This is what is essentially it is doing. And then when I print P1 minus P2, it gives me the right answer. Now we can look into this part. What is actually this? So this is obviously a function of the long type integer. I want to return the number of points, or you can call this, not rather S, you can maybe call this P, number of points. And then I pass R, I pass E. Now what I've done over here is the range of X. All right. So like, let's say I want to calculate less than R plus 1. So to calculate less than R plus 1, E would be 0. If E would be 0, it would simply be like, it would directly mean not to even write this, it's good, right? This would be the essential case. E is 0. Now, if E is 0, can you imagine this? I would be running a loop from 0 to less than equal to R, because if I want to calculate less than R plus 1, I know the maximum R I can go is, maximum X I can go is actually R. So from 0 to R I run, then I calculate the difference. That's the I calculate the Euclidean distance. This would be, now because I want to calculate less than R plus 1, the equation essentially would be plugged in with R as R plus 1. So this would actually be R plus 1 square. So I calculate the Euclidean distance, that is R plus 1 into R plus 1 minus X into X. So I take X over that side. I will essentially now calculate Y square less than R plus 1 square minus X square. Yes. And then this is the Y. It's initially nothing. I have a binary search. Binary search starts with L0. That's the lower bound. And then high H is R. That's the maximum I can go. Yes. Now I run this binary search and then I find the mid. If I feel that this mid into mid is less than D, then it's a possible answer. I store it and I increment my L because I want the largest place where I find the T value, the monotonic T to be true. That is why I would increment my L. Store this as a potential answer, increment my L, or make it mid plus 1. Else I make H to be mid minus 1. Is this clear to everyone? Now, what would I do? If X is 0, then I will only add Y into 2 plus 1. And if X is not 0, I will add Y into 2 plus 1 into 2 again to have that symmetry of like, for this side I calculated, then I also want negative X values for the negative X to be the same part. Now, once I have realized this function's utility, I want to manipulate this function to take into consideration the next time I want to do the same thing with less than R. So that is why I like quickly maintained an E variable. What would happen is now, let's say now I passed E. E is -1. So now essentially E would be acting as -1 in this. All right, -1 in this. So that would essentially mean now you are running like, because you want less than R, you will run from 0 to R minus 1. The calculation is actually R into R minus X into X, right? And then the L is 0 to R minus 1. Is this clear to everyone? Yes? I mean, basic implementation. I mean, it's not a very tough implementation, right? Whatever hit me that time, I just did that. Again, you can directly pass maybe this variable and it's not going to be a problem. The basic part is like, I try to be D. All right, what is D? All right, so D is the Euclidean distance. D is the Euclidean distance. Like, not exactly, all right, so not Euclidean distance, I should say. D is actually this variable. Like, let's say, X square plus Y square less than R square is something I wanted to calculate. Then I shifted X to this side. Y square is less than R square minus X square. And then I took this value as D. So now I have a very direct check for D. Clear? Can you please dry run on a small case? Can I dry run on a very small case? All right, so this is going to be interesting. Let me do this. Let me not dry run. I'll print you directly and you will see what is happening. I'll print Y to you. All right. Let's see what happens. I'll print y actually, and then maybe I'll drop out a line also so that you get the whole idea. All right. So first, let's see. Can you see this? The answer, let's say I discuss the answer for 3. So I am getting all the maximum y's less than r plus 1. So to get a Euclidean distance less than r plus 1 for the plugin of r plus 1. So can you see this diagram? Like if x ranges from 0, 1, 2, 3, what is the maximum y am I getting? 3, 3, 3, 2. Can you see this? I'm getting 3, 3, 3, 2. Yes? Makes sense. And then when I do this for r, what points am I printing? 2, 2, 2. Now, what is r? Less than r means less than 3. So less than 3 means 2, 2, 2. This is the red part. 2, 2, 2. So don't I get this? So somehow I have finally gotten the correct answer. Like I can like you can very well see the y is getting correctly outputted. Yes, same can be cross-verified for next parts also. Same for next parts. And then again, this part cannot be drawn, the last case, but then you get the idea. Yes. So I am getting the correct y which I wanted. I wanted for like, let's say I was calculating for d less than 4, sorry, r less than 4. I wanted this y towers of like 3, 3, 3, 2. If I would have calculated them quickly and easily, I would have calculated the correct answer. And this is what I did. And same thing I did for less than r. I calculate these towers, the red towers 2, 2, 2, maximum y from 0, 1, 2. That's why I'm getting only printed 3 values, that is 2, 2, 2. So I am overall getting this correct values. Now, when I actually calculate the answer, this p value by this symmetrical mathematics, I will be getting the correct part. Because if let's say I'll print this for you. All right. So let's say I printed P1. All right. And let's say I printed P2. Then what do you think will I get? All the points for which I have less than, like for if I was calculating for 3, then first all the points less than 4, then all the points less than, I should say, less than 3, right? So can we see this? All the points less than 4 is 45. All the points less than 3 is 25. Subtract both of them, you get 20 answer. And I can see I am getting 45. Like all the points less than 4, I do have 45 points. If you calculate all these points, like count all this, 8, this is 16 points, this is 10. You are getting a total of 45 points. Is that right? You are getting 45 points. So are we clear on the approach now? Yes. I've literally like just printed out the variables for you guys to make you understand that this is working. All right. So Omkar. All right. So Omkar wanted a dry run. Did we get this? Yes. So let me just remove these comment parts. And we got a clear, well-viable solution that this was the binary search part. So now if I ask you what's the time complexity, you will report the time complexity to be like this part is again running in a time complexity of r log r. This is also running in r log r. So you can say that overall time complexity is actually r log r plus r log r, which is 2 into log r, 2 r log r, which is simply r log r. And then what about space? Am I using any extra space? No, I'm not using any extra space. So that means space is O of 1. So an r log r solution gets, right? No. All right. So you're saying no. Why no? What, am I doing something wrong? No space. All right. No space. All right. Fine. That's great. So I don't have any space, right? I have a constant space. Cool. So fun problem, right? Interesting implementation based problem. Can we move on to the next problem? Final problem of today. And again, this is a very like I think I've solved something like this previously. So this problem was something I actually got through much quicker than the other problems. All right. So let us discuss this idea. Can we now begin with this problem? Yes. Final problem G. All right. So problem is named X something XOUR. How do you spell this? XOR only maybe. Problem states, given an array A consisting of n non-negative integers, you can swap at positions I and j if you think that AI XOR AJ is less than 4. So the condition is you need to do swapping. That's great. They have given you the power to do swaps, but they have restricted you to only swap when you think the numbers which can be swapped should have the XOR value less than 4. Less than 111. Less than 111. Also, so 111, also 111 in binary format is 7 actually. So less than 7. Less than 100. Right? Cool. I think I mean you get that, Adarsh. Yes. So we need something that's below 4, the XOR of AI AJ. If that's possible, I swap them. Now I want to form the lexicographically smallest array with any number of swaps. So again, I'm not limited to the number of swaps. I can do whatever the reasoning I feel it's okay. Yes, but then I'm limited by something that's this condition. So let's first try to analyze this condition. All right. Let's say there are two numbers. Let's say this is X number and then this is Y number. Let's say in the binary format, like in binary format, I have bits as X1, X2, X3, or rather from the backend side. Let me form this from the backend side. Let's say I'm only considering from the back side. So let's say this is 0th bit, X0, X1, X2 bit, X3 bit, X4 bit, so on, so on, so on. Let's say maybe something like this. And then I have a second number Y, Y0 bit, Y1 bit, Y2 bit, Y3 bit, Y4 bit, and so on. Cool enough? Any problem with this? Now, I know that I want a number less than 4 when I XOR them. Yes, less than 4. So if I know that I want number less than 4 after I XOR them, what is the property of XOR? Can anybody tell me? Like, can you tell me like 0 0 XOR gives me 0? 1 0 XOR gives me 1. 0 1 XOR also gives me 1. 1 1 XOR gives me 0. This is a XOR table. Yes, I have a quick XOR table with me. So now tell me, like I'll try to build the intuition. If I talk about, like, if I ask you whether or not you think X number and Y number can be swapped, to actually answer this query, difference gives 1. Difference gives 1. At most 2 bits differ. All right, so kind of getting the idea. A left shifted to 2 is same. Correct. Makes sense. Yes, right shifted. Correct, right shifted. Makes sense. All right, so what Mohit is saying is, or what idea do you actually get is, am I concerned with these 2 bits, X0, X1, Y0, Y1? My argument is no. Why no? Because these bits are actually representing the number in power format. Either this is a 1, this is 2 power 0, that's 1, or 2 power 2, this is 2. So if the bits over here are turned on, off, whatever they are, in both the number X and Y, when I would XOR them, I would receive some bit over here. Let's say I XOR them, I receive the bit Z1 and Z0. Z1 and Z2, if they are 1, if they are 0, they are both turned on, both turned off, 1, 0, 0, whatever combination they form, I know that this part is definitely less than equal to 3. These up till here, the number is maximum less than equal to 3. Yes, for only these 2 bits. Now, anything beyond that, all the bits beyond that, that is the segment over here and the segment over here. If let's say the bit X3 is 1 and the bit Y3 is 0, then what would happen? When you XOR them, will you not receive a bit 1 over here? Because 1 0 is a XOR. Simply arguing that if some ith bit after the 2-bit indexes in both numbers are opposite in nature for some ith position, then you will turn that bit on while you XOR that number. Is that right? If this is the Zi bit, will not Zi be turned on if they are 2 different bits? If it's a 1 0 or a 0 and a 1? Yes. And do you think you want them to be turned on? Like, do you think you want that 1 and 0 or 0 or 1 something you get, or you get 2 different bit? Do you want that? No, I don't want that. Because if that happens, some Zi bit is going to get turned on. It is going to become 1. And this is going to contribute to make my XOR value greater than 4. It's definitely going to fetch me a value greater than 4. Is that right? And because it will fetch me a value greater than 4, I know that X and Y are not swappable. Are they swappable? So that means the y2 and x2 XOR should also be 0. Exactly. That means all the bits from after x2 and from after y2 should be same. Is that right? Can we all agree to this? Or like what Mohit said, or some comments said, if you actually like right shift, I'm sorry for that, you right shift this whole part, x and y, 2 bits, all right, then you can very clearly see that I will receive the, like if what is the essential meaning of right shifting? Right shifting means I will be negating these 2 bits. Now these 2 bits are no more because I've shifted 2 times. So the number is looks only like this. The only numbers, x is this number, updated number, and y is this number. Now if these 2 numbers are not same, if these 2 numbers are not same, then I know that they are not like, I should say, like they are this number, like x and y in itself will never be swappable. And if these numbers are same or of the same type, whatever you can call that, you know that these numbers are swappable. Yes, do we all get this? Do we get this? So that means I have a solution with me now. Now what I can essentially do is, next comes the next part, lexicographically smallest. Now lexicographically simply states that if you finally make the array after some swappings or something like that, you want it to look as small as possible in the manner that it's sorted. Now tell me, now I've done again a very not a very clean part of code, right? I could have implemented with right shifts and stuff like that, but I did not want to go into a lot of, maybe I mean I don't know why I did not do that. Again, implementation is not a big part, but then idea should be clear in this, that let's say like lexicographically what the idea is, I'll call the number to be of some type. All right. So let's say I had the numbers A1, A2, A3, A4, A5, A6. I have 6 numbers. On this, I have total 6 numbers with me. Now, let's say that the numbers A2, A3, and A6, the numbers A2, A3, and A6, after you would have right shifted their 2 bits, or simply saying that if let's say the numbers A2, A3, and A6 had all the bits same after the second bit index from the left hand side in the 0th bit format, then maybe I can call them as part of a group. Yes, can I call that? Can I mark them? Like, let me mark them with the red. Can I say that this is part of a group, of a same group, of swappable structure? All these numbers are swappable. A2, A3, A6 can be swapped among themselves. Can we all agree to this? Because they have the same looking structure after the second bit, then A2, A3, A6, you select any 2 numbers, they are swappable. Because they will give you a XOR value less than 4. Do we agree to this? Yes. And then the next argument is, if that is the case, then lexicographically, will I not prefer greedily to keep the lowest number in A2, A3, A6 at this position first, then the second lowest number at this position, and then the largest or the third lowest or whatever you can call that number at the final position? If these numbers are swappable, A2, A3, A6, and let's say the smallest out of them was A3, then don't you think A3 should come over here? Let's say the next smallest was A6, A6 would come over here, and A2 would come over here. If I want lexicographically the smallest stuff. Do we agree to this? Yes. So because of this, I know that my idea now dictates in the direction. If I'm able to somehow push all the numbers, like I'm able to get all the numbers in some, like through some implementation, I'm able to first identify what numbers are of the same type, right? Why am I using type actually is because that is how I've implemented the code. All right. Again, you can use right shift and stuff like that. So that's also clean. But then again, map has to be used in this. So that's not a big problem. So like, let's say I'm able to identify the type. type means pair. No, type is not the pair. All right. So what I mean by type is actually like type means is what are the numbers which have the bits same after greater than equal to x2 bit, or the second bit actually. All those having the same configuration. All right. Also, that's a good word. Right. Maybe I can keep this as configuration. All right. So configuration. All the numbers which have the same configuration, right? Config can be kept together, and they can be sorted in an increasing order and then placed back as it is in the array. If I do this for all such configurations, then will I not receive the best possible lexicographically smallest array? Let's say I realized that A1 and A4 were having the same configuration and A5 had a different configuration. Then let's say A1, A4, the lowest out of this was actually A4. So A4 comes over here and A1 comes over here, and then this is A5. Then can't you argue that this is the best configuration possible? Because you have increasingly set all the swappable numbers in an increasing order. So because A1 and A4 were in the same swappable set, configuration having same, if you kept them in an increasing manner, assuming like let's say A4 came before and then A1, right? A2, A3, A6 being in the same configuration, place them again in increasing manner, and then A5 is kept as it is. So do we get this idea? Same configuration having same thing, so I can work it out. Yes. All right. So that means once I understood this, can I now look at the code part? Yes, because now everything is implementation, right? Because like diff for contests are all about implementation. Idea is clear. Implementation is going to be maybe a bit technical to understand. All right. So I'll go to the implementation part. All right. So this is implementation. What I've done is I've taken the array, right? And then I've taken the map. Now map is of the like G was easier than E and F. Correct, exactly. That's actually what my argument was also, right? G hit me much more quicker. So you create a map of I've taken the key to be long, and the type is vector. So what is essentially is going to represent is I'm going to push back all the numbers in a vector which have the same configuration. So for a config, I'm going to push all numbers, because that would mean that all these numbers having this same configuration are swappable and can be set in an increasing order. Yes, agreed. This is what I've used the map for. All right, now I have made a very tedious piece of code, so keep up with me. I mean, I'll optimize this a bit more, and I'll then post it out as a submission. That's not going to be a problem, but then if I explain this out, you will see that it's very basic to understand. And I mean, maybe there is some small optimization that can happen in this, but then that's totally up to you. So I'll go to every number in A. That number is IT. All right, and then what I'll do is, this is the type which I was talking about. Let me actually make this as config. All right, this is config. Then what I'll do is I am going to figure out what's the config of this number. How do I figure that out? I can like directly write IT shifted 2 times to the left. That's also right, correct? Or by simple binary solution, you can simply like to calculate actually the bit formats. You can actually do this also. You can actually you can decrease it every time with a single bit. And if you think that the current bit is 1, you add on to that config, that's 1 left shifted to in, and you increase in by 1. That's the index on the bits that's running from that part. So this becomes a direct part. This becomes a direct code approach, simply writing IT left shifted 2 times. If you don't want to write that, this also is a correct approach. So once I find the config, like however you find the config, that's not a big part. You find the bits, like the number representation of the configuration after removing these 2 bits, you can push back in that configuration this number IT. Yes. So this will get you a map having keys as the all possible configurations, and then corresponding to every key there would be a vector with some greater than equal to 1 numbers in count which had the same configuration. So then what you can do is you can sort that. You want to sort that map. Yes, don't you want to sort that map? So I'll sort that map. What I'll do is I'll go to every I am using a reference to this map, and this it.second is the vector. So I'll sort it.second by calling the stl function. So that sorts me the vector. Is that clear? I have now a sorted vector with me. sort, like for every key, I have a sorted vector. Yes. Now, what do I do after this? Now I've created one more map. This is for the indexing. Like why I did this is because I received a TLE when I did this without. Maybe you can do this without this also. That also works. What I'll do is I will map, like what I want to do is essentially, I have mapped, let's say this is configuration 1. To configuration 1, I have the numbers A1 and A4. To configuration 2, I have the numbers A1, sorry, A2, A3, and A6. And to configuration 3, I have the number A5. Yes. So what I'll do is I want to, like in this vector only, I want to maintain a pointer so that I like an index pointer, which initially all points at 0, so that I'm able to iterate in this vector itself. And I'm able to create a new array which has this looking structure, A4, A3, A6, A1, A5, A2. So for that, what I've done is I've taken another unordered map. This is unordered. Because I wanted a very low time complexity. And in this, I don't want to, like, I can do without a ordered map also, because this is of the simple pair and key type, right? Key and value type of long. And then I have done iteration. I have done a mapping of the first map, that is MP, it.first, that's the config, with mapped with 0. That's the initial index that starts within that vector. Now, when I go to every number in that number A, I am using a reference type. I'm using reference IT. Why am I using reference IT? Because I want to change that number directly. So I'm using reference IT. Do we get this? Like, do we understand the difference between writing this without an ampersand and with an ampersand for a while loop, for a for loop? Yes, with an ampersand, you will be directly manipulating that value because you are actually accessing that value directly in its memory. But if you don't put an ampersand, you are actually iterating in a copy of that value and not that value itself. So I use an ampersand IT. That means the IT value I receive is actually the value in the array A. And then I again find the type. So that's the same piece of code I just copy pasted from the above, or rather the config, if that's the correct word, right? Config. And then once I have the config with me, what I can do is actually, I think this is boilerplate. I don't need that line, right? I know MP size is greater. Then what I can do is I can manipulate the IT value by saying that this IT value is going to be the new value that is in its same configuration, the index which was actually kept in the configuration, in the index map, that is IND map. So it fetches 0, and then I increment it to the next index. Next time it is going to point 1. Next time it is going to point 2. Next time it is going to point 3, so on, till that time that segment had those count of numbers available. Is this clear? Like, this is not a very complex implementation. I just wanted to somehow like not take vectors of vectors to store this individual segments, and I want to do it directly. So that is why I did with two maps. You can implement this any method you want. And then this finally manipulates IT itself. So you can very well see, like, after I've printed this IT value, if I print this array before, you will say that this array is as it looks like. And after actually I print this array, you will see that the array has now got manipulated. Can you see the difference? Like, this answer was already kept as it is, but then this answer has changed, this answer has changed, and this answer has changed. Yes? Please explain line 50. All right, cool. Line 50, 53. All right, cool, 53. So what I'll do is, from the, like, in the MP of configuration, when I write this part, MP of configuration, this calls the vector. This is equivalent to saying, now I have a vector. Yes, MP of configuration is the vector. So I'm calling the vector which had the key as that configuration for the IT number. Yes, got it? And then inside that vector, I want the next index. Now that index is something I'm again calling from this index unordered map, because I want indexes to increase every time I've used a value. So initially it starts with 0. If I've used the value, it's basic indexing, correct? It's basic indexing vector. Next time it increases. It becomes from 0 to 1. Then 1 to 2, so on. Agreed? And now if I dry run, like I'll dry run this out piece of code for you on, like I'll dry run for this second case for you. So in the second case, the numbers 1, 5, 2, 6, 7 were given to you. Like 1, 5, 2, 6, 7. In this, can you tell me very clearly that which numbers are going to have the same configuration? Like, I can very clearly see that 1 and 2 are the same configuration numbers, and 5, 6, 7 are the same configuration numbers. Yes? Is that right? Like initial array was actually something that looks like, initial array looked like 2, 2, 7, 1, 5, 6. So I know that 2 and 1 are the same configuration, and 5, 6, 7, this 7, 5, 6, whatever, are the same configuration. So if I've undefined the same configuration numbers, if I sort them at place, then this becomes 1, 2. This becomes 5, 6, 7. And that's the answer. Can you see the answer matches? 1, 5, 2, 6, 7. It matches. So our logic matches. Yes. So this is going to fetch you a correct piece of, this is going to fetch you an AC. All right, now I did this map, store, configure list of indices, then sort them and number. Correct. Like again, Mohit, that's part of implementation, right? So kudos to that. I think like doing this with map is something that has to be compulsory, but then after a map, maybe you can maintain a list or some indices or maybe some other pointers, something like that. Like you wanted something, like you wanted to maintain some pointers, because we want to in place sort them. We don't want to change the order of sorting, right? You want them to have an in place sorting, right? All right, so big part done. And now can we discuss the time complexity? Now I'm using a map over here. All right, so everything in this is working in log of n, right? So I would have a n log n solution over here to run this. This is O of n log n. N is coming from the iteration on every number, and then log n comes from this pushing back. All right, so creation, insertion in the map is actually the log n time. And then this sorting time, this sort for loop is also running in O of log of n. Can you tell me why? Why do you think that's the case? Like you are going to every vector of the map and you are sorting it. So on an average, it is still n log n. Yes. Because like you can imagine it like this. What can be the worst case and what can be the finest case? Worst case can be every number has a different configuration. So if every number has a different configuration, the size of the map is n, and in every n array you are sorting, but because every number has a different configuration, the size of the vector will be only 1. So in the worst case, you will have a loop that like you will have this loop running in n into this would be 1 log 1 sort of a like I mean 1 log 1 is something that's not there, but you get the idea, right? You will be sorting only one number. That's great. But then if let's say the worst case is, let's say sorry, the finest case is, let's say every number had same configuration, then the size of the map would be 1, but the array size would be n log n. So n log n would be the complexity to sort it. So in the first and finest case, both you can see you have an n log n complexity. So that means somewhere or the other in the middle part, exactly Adarsh, that's the point. Ultimately, the average sum of all the elements in the vector is n. Yes, the sum of all the elements in the vector sum is n. So when you actually sort them, you take an n log n factor to sort them, but that n is always changing, it's dynamic, and that n is actually adding up to give you a net sum of n. So that's n is not n actually, it's like n1, n2, n3, n4, all different sizes of total numbers, but everything adds up to give you a total vector of n size. So average time complexity of this is also n log n. And now I have used an unordered map. So you have O of n solution over here, right? This is O of n inside this O of 1 to actually map it. So that's not a big deal, like worst case O of n. And then this is O of n inside which I have, like I am only calling the numbers. I'm not pushing back anything, right? And this change in the index unordered map is O of 1. So this is O. So I can call this as O of n solution overall. That means overall I have a like superseding solution as like best solution, worst solution is running in O of n log n. Yes, the time complexity is going to be like in an order of O of n. Worst cases, like let's say all numbers are of different configuration. So that's the case because I'm using maps, right? So n log n solution will work, definitely. Yes, I have a 10 power 5 order. That means it definitely works. And that's going to fetch me a correct part, correct AC. So is like ultimately the goal of the problem clear? Yes, I think we are to the end of our PCD now. And TSU tag. I don't know why there's a TSU tag in this. All right, so like tags behind this is actually like related to how the masters and the international masters can actually change the problem tags for themselves. All right, so like maybe there's some idea with DSU, right? I did not picture that. I mean, you obviously have a component, right? So maybe they are working that as a set, because we are making a set of numbers which have the same config. So maybe that's why DSU. You can maybe create a DSU structure, push all the numbers in that same configuration, and then maybe use them to sort them out. That's also great. All right. So that brings us to the end of our PCD. Let me stop my screen share. And let me stop. Thank you, everyone. Let me stop the recording.